Okay, this is the review for Math 2020, the second exam, covering chapters 10 and 11. Okay, question 1. All we need to do is represent this statement here symbolically. So, angle ABC, this is the symbol for congruency, is congruent to angle LMN, or LMN. Similar thing for question 2, the line containing points Q and R. Okay, but what you ought to be prepared for, in questions 1 and 2, are other things like array that contains the points Q and R, or a segment with endpoints Q and R, or in question 1, for example, the measure of angle ABC is equal to the measure of angle LMN, just different sort of mathematical symbols that we learned to represent relationships in geometry. So those are some things to look at back in chapter 10.1, 10.2. Question 3. We have two angles, angle A and angle B. The first, it says measure A is 15 more than 3 times measure B. The sum of their measures is 195 degrees. So what this means is if we have the measure of angle A plus the measure of angle B, that's equal to 195 degrees. It also says the measure of angle A is 15 more than 3 times the measure of angle B. So we've got 3 times measure of angle B and then 15 more than that. So that's what the measure of A equals. So using substitution, we can take this quantity and substitute it in for the measure of angle A. So instead of the measure of angle A plus the measure of angle B equal to 195, we can turn this into 3 times the measure of angle B plus 15 plus the measure of angle B equals 195. This simplifying and combining like terms is 4 times the measure of angle B, and then if you subtract 15 from both sides, you get 180. And if you divide 180 by 4, you get 45. So the measure of angle B is equal to 45. And the very first statement we had written here was that the sum of the two angle measures, measure of angle A plus the measure of angle B, is 195. Well, if we know that measure B of angle B is 45, then that means measure of angle A has to then be 150. Okay, so measure of angle ABC, I know the diagram's kind of hard to read, but here's ABC right there. The whole measure of the angle is 170 degrees. DBC, that part of the angle, is 130 degrees. Determine the measure of angle ABD. So ABD is that piece of it right there. Well, if the whole measure angle ABC is 170 and DBC is 130, that means the measure of angle ABD is equal to 40 degrees. Okay, question 5. A, B, C, D are collinear points. C is the midpoint of AB. A is between D and C. AB equals 16 and BD equals 26. Find AD, or find the length of distance between points A and D. Now, A, B, C, D are collinear just means they lie on the same line. They don't necessarily have to come in that order, A, B, C, D. It says here C is the midpoint. Where is it? Right here, C is the midpoint of AB. That means C is right in between A and B. And it says here that A is between D and C. So we have a line. It says C is the midpoint. Of AB, so from A to C is the same as from C to B. And it also says that A is between D and C, so D is somewhere over there, so that A is between them. From A to B is 16, and from B to D that's 26, so find the measure from A to D. It's got to be 10, because 10 plus 16 is equal to the full distance of 26. Okay, number 6, what words do we use to describe relationships amongst points? Well, we just use one of them up question 5. Points can be collinear. A group of points can also be coplanar, so I'm going to write collinear. Coplanar. But if lines aren't in a straight line, if points aren't lining up in a straight line, or if points are not on the same plane, then we could say they're non-collinear, or non-coplanar. As far as what we learned in Chapter 10, those are the words used to describe relationships amongst points. Now, extending this idea, think beyond points. What kind of lines what kind of words did we use to describe relationships among lines? There's parallel lines, there's perpendicular lines, there's skew lines. So think about other relationships as well, just not relationships amongst points. For page 2, what measurement tool or what instrument do we use to quantify the openness of an angle? It's a protractor. Okay, question 8. Angle DBE is 40 degrees. FBD is 80. And the measure of angle ABE is half the measure of angle DBC. Determine the measure of angle ABD. So we're trying to find that measure there. Well, first to find this measure of this angle EBC, we can use the fact that angle FBC is 180, or a straight angle, and we know that from here to here, that portion of it is 120 degrees. So in order to make 180 degrees, that's got to be 60. So EBC is a 60-degree angle. Well, why do we need to know that? It says half the measure right here of angle DBC. Well, angle DBC is that angle right there. So angle DBC is a 100-degree angle. Half of that is 50. So we know that angle ABD, or sorry, ABE, this one right here, we know that that's 50 degrees. So from here to here, we know it's 50. From here to here, we know it's 40. So that means this has got to be 10 degrees. So the measure of angle ABD is equal to 10 degrees. Number 9, a ray with an endpoint A and heading towards a point B. So that's mathematical symbolic notation for ray with an endpoint of A containing point B. For number 10, a line M is parallel to line N. So M parallel to N. Okay, question 11. These are some of the angle pairs we talked about. We've got vertical angles, complementary angles, supplementary angles, adjacent angles, and then all of the angle pairs formed by two lines and a transversal, like corresponding alternate interior, those sorts of things. Angle A and angle B happen to be vertical angles, and the thing to remember about vertical angles is they are congruent. So B is also equal to 40 degrees, because the measure of angle A is equal to the measure of angle B. Okay, question 12. First thing to note is that we're talking about a triangle, and in a triangle the measure of, or the sum of the measures of three angles is 180. So that would be the first thing to realize, is measure of angle A plus measure of angle B plus measure of angle C is equal to 180 degrees. Then it says measure of angle B is 26 degrees more than 3 times measure of angle A. So 3 times measure of angle A plus 26. And then it says angle C is 26 less than the measure of angle B. So measure of angle C is measure. Okay, if we make some substitutions here into the original statement, measure of angle A plus measure of angle B plus the measure of angle C, I'm going to substitute these two expressions in there. So measure of angle A now, instead of writing measure of angle B, I'm going to substitute this expression here for the measure of angle B. So 3 times the measure of angle A plus 26. And then instead of plus the measure of angle C, I'm going to substitute this expression for the measure of angle C plus measure of angle B minus 26, and that's equal to 180. 26 and negative 26 cancel each other out. So we've got 4 measures of angle A plus measure of angle B is equal to 180. Now I'm going to replace the measure of angle B again with this substitution. 3 times the measure of angle A equals plus 26. So 4 times the measure of angle A plus 3 measure angle A plus 26 equals 180. So now we've got 7 measures of angle A. To subtract 26 from 180, 154. 154 divided by 7 equals 22. So the measure of angle A equals 22 degrees. It says the measure of angle B is 26 more than 3 times that. So we take 22, multiply it by 3, we get 66. If we take 26 more than that, we get 92. So measure of angle B is 92. Let me write this up here. Measure of angle A equals 22. Measure of angle B equals 92. And it says for the measure of angle C, it's 26 less than measure of angle B. So if we have measure of angle B at 92 and take 26 less than that, we get 66. One thing you should always check is, does your answer make sense? These 3 angles are supposed to be the measures of the inside of a triangle, so they should add up to 180. So if we have 66 plus 92 plus 22 equals 180. Okay, 2 angles are supplementary angles, so measure of angle A plus the measure of angle B. Supplementary means that their sum is 180 degrees. The measure of the larger angle is 6 more than 3 times the measure of the smaller. Now, it doesn't specify which one's larger or smaller. I chose to use A and B, so I can choose just that A is going to be the larger one. It doesn't really matter. So I'm going to say A is the larger one. So the measure of the larger one, A, measure of angle A is 6 more than 3 times the measure of the smaller. So 3 times measure of angle B plus 6. This question is a lot like number 13, just less intense, so not as much to do. So making the substitution into the measure of angle A, we have 3 measures of angle B plus 6 plus the measure of angle B is equal to 180. So 4 measures of angle B by combining 3 measures of B plus 1 measure of B. And then if you subtract the 6 from 180, you get 174. So divide 174 by 4, you get 43.5. So measure of angle B is 43.5 degrees. We know that A and B together form supplementary angles. So if we subtract this amount from 180, okay, that wasn't it. Okay, 136.5. So measure of angle A is 136.5. Okay, true or false? Every rectangle is a parallelogram. Well, the only requirement to be a parallelogram is it has two sets of parallel lines. If you think about a rectangle, the sides are parallel and the top and bottom are parallel, so it does have two sets of parallel lines, so a rectangle is a parallelogram. So that's true. Again, though, you ought to recall some of the other statements you had in your homework regarding quadrilaterals, such as 15. Some squares are rectangles. So, I'm not too thrilled with this question, the way it's worded, because when it says some squares are rectangles, it implies that there are squares that are not rectangles. So think about the definition of a rectangle. A rectangle has to have 4 right angles. That's the only requirement to be a rectangle. And then if you think about a square has 4 right angles and 4 congruent sides. So it's the statement should read all squares are rectangles. So I'm going to say this is false. All squares are rectangles, not just some squares. Okay, Randy here drew 2 lines cut by a transversal, and it says here that the measure of angle 6 is congruent to the measure of angle 7. Those are alternate exterior angles. Sandra shouted, "Hey, lines M and N are parallel." I don't like this being just a yes or no question. It should read, show that Sandra is correct. So, how can we show that that Sandra is correct? Well, one of the theorems we talk about in class is the corresponding angles theorem. If 2 angles are corresponding, or if 2 corresponding angles are congruent, that means the lines are parallel. So we could say this: angle 7 is congruent to angle 4 because of vertical angles theorem. Okay. So that implies that angle 6 is congruent to angle 4. And the way that we know that is the measure of angle 6 was congruent to the measure of angle 7 that was given. So if the measure of angle 6 is congruent to the measure of angle 7, and the measure of angle 7 is congruent to the measure of angle 4 by vertical angles, then we can conclude the measure of angle 6 is congruent, or angle 6 is congruent to angle 4. Because if A is equal to B and B is equal to C, then A is equal to C. Now, if angle 6 is congruent to angle 4, that means lines L and M are parallel. So M is parallel to N because angle 6 is congruent to angle 4 and angle 6 and 4 are corresponding angles. Angle 6 is corresponding to angle 4. That was one of the theorems we learned about in the book and during our discussion, that if you can show that corresponding angles are congruent, that means the lines are parallel. So now we're trying to prove that measure of angle 5 is congruent to the measure of angle 8, alternate exterior angles. Is Pam correct again? Instead of having this just be a yes or no, how would we show that? Well, the reverse of the corresponding angles theorem, if two lines are parallel, then corresponding angles are congruent. So we could say, because M is parallel to N, angle 5 is congruent to angle 3. And then we could say angle 3 is congruent to angle 8, and that's because they're vertical angles. So if 5 is congruent to 3 and 3 is congruent to 8, then angle 5 is congruent to angle 8. Okay, number 18, what kind of triangle has 3 sides that are all different lengths? It's called a scalene. Okay, but you should run through your head some of the other names of triangles. We have, by angle measure, we have a right triangle, or an acute triangle, or an obtuse triangle. By side length, scalene means all 3 have different lengths. An isosceles triangle has 2 congruent lengths. An equilateral triangle has all 3 sides congruent. Okay, number 19. Complementary, supplementary, adjacent, or vertical. So EGF, and FGA. Okay. Those two are adjacent because they share one side in common, and the measure of the two angles is 90 degrees, so we would say complementary. Now I'm not just saying they look like they're 90 degrees, you have to use markings on the diagram. The marking given here means that that angle is 90 degrees, and this is a straight angle, so that also means that has to be 90. Alright, triangle ABC is a right isosceles, so right triangle isosceles means those could be the congruent lengths, and A is the right angle. Rather than saying select triangle ABC, it really just means to draw. This was originally a multiple choice question. I changed it into just a free response, so it should say draw triangle ABC. Okay, question 21. ABCD is a right trapezoid. First of all, a trapezoid is a quadrilateral, so the measure of all 4 angles is 360 degrees. It's telling us that this is 110 degrees. These are 90. So 110 plus 90 is 200, plus another 90 here for measure of angle A is 290. So measure of angle D equals 360 minus 290. And equals 70. We classify polygons by the number of sides. Like a triangle has 3 sides, a quadrilateral has 4 sides, a pentagon has 5, and so on and so on. Okay, 23. Name all vertices, edges, and faces for the given right pyramid. So let's start with vertices. We just have A, B, C, D, E, F. edges. We have AB, BC, AC. We have BE, EF, CF, and BC. But we already had BC mentioned over here, so we don't need it again. We have ED right back there. And we have AD back there. And we have DF. Okay, for the faces, we have the two bases, ABC, triangle ABC, and triangle EDF. And come to think of it, to be more precise, well, let me finish this. Triangle ABC, triangle DEF. Back here when we're talking about edges, the edges are segments, so these should all be segment AB, BC, segment AC. So I'm going to put segment markings here. So we have the bases, triangle ABC, triangle DEF, and then we have three lateral faces that are triangles. We have this triangle here, which is BEFC. Rectangle rather, not a triangle. We have the one on the bottom, ACFD. That's another rectangle. And we have this rectangle on the side, which is ADEB. Alright, 24. Pyramid has 36 faces. How many lateral faces? So lateral faces means faces that doesn't include a base. Now if you think about the difference between a pyramid and a prism has two congruent shapes, like a triangle, two congruent polygons that are also, the planes are parallel. And then the lateral faces are rectangles. On a pyramid, it has one base. And all the other faces are lateral faces. So if a pyramid has 36 total faces, one of those is the base, so it's got 35 lateral faces. Okay. Similar type of question. The base of a pyramid has n sides. How many lateral faces does a pyramid have? Well, if you think about, we can just draw the net of a pyramid. Let's say the base is a square. Then it's going to have these triangles coming out, and those triangles would be folded up to form the prism. So if the base was a square, it had four sides, that means it had four lateral faces. And that would be true of any base polygon for a pyramid. The number of sides of the base, n in this case, is equal to the number of lateral faces, so n lateral faces. Okay. So the base of a prism now has n sides. How many faces? And this isn't just lateral faces, it's how many faces total does the prism have. So similar, if the base of a prism has n sides, that means the prism has n lateral faces. But a prism also has two bases. So you have to include that into there. So it's 2 more than n. So we've got n plus 2 faces. what's the measure of an interior angle of a regular polygon with n sides? We talked about this in class, as it was on your homework as well. A good way to remember it is based on number of triangles. For example, a quadrilateral like a parallelogram or a rectangle. It's got 4 sides, but there's 2 triangles. If you think about a pentagon has 5 sides, but you can break it up into 3 triangles. So the number of triangles inside a regular polygon is always 2 less than the number of sides. And why the triangle? Well, we know that the sum of the angles in a triangle is 180. There's 3 angles. They all add up to 180 degrees in a triangle. So if you have a polygon with n sides, that means there's n minus 2 triangles that polygon can be broken up into, and then you multiply it by 180 degrees, because there's 180 degrees as the sum of the angles in a triangle. And then you want each interior angle of the regular polygon, so you divide that by n, the number of sides. For example, a hexagon has 6 sides, 6 interior angles. Okay, how many faces does a hexagonal prism have? Well, a prism has 2 bases that are congruent, same size, same shape, and then it's got the lateral faces. It's got the same number of lateral faces as the number of sides of the base. A hexagon has 6 sides, so it's got 6 lateral faces plus the 2 faces that make up the base. So this has 8 faces. So using this little scale here to measure the nail, it comes in right about there. We round up to the nearest tick mark, which is that tick mark. The precision here shows that it's to the thirds. It's breaking the inch up into thirds. So this is 1 of the thirds. That's 2 of the thirds. Plus the 1 inch here, so it's 1 2/3 inches. Okay, we've got 15 blips equal 4 lugs, 7 lugs equal 13 gifts. How many blips equal 5 gifts? Okay, so we've got to go from blips to lugs, and then from lugs to gifts, it looks like. So starting with 5 gifts, I want to change the unit of measure of gifts into lugs. So if I want to cancel gifts, I want to put gifts down here and lugs up here. So 7 lugs equal 13 gifts. So now we're measuring in lugs and not gifts, but I want to not be in lugs, I want to be in blips. So I got to multiply by 1 more conversion factor here. I want to cancel lugs this time, so lugs is going to go on the bottom and blips goes on the top. So 15 blips equals 4 lugs. So now the lugs unit of measure is gone and we are in blips. So 5 times 7 times 15 is 525. And 13 times 4 is 52. That's about 10.1. Blips. 5 gifts is equal to about 10.1 blips. Okay, what's the connection between the precision of a rule and the GPE, the greatest possible error? This was back in 11.1. So, looking back at this nail problem up here, question 29, This nail wasn't quite all the way to 1 2/3 inches, but we had to round. And that's going to happen, you know, depending on how precise your measurement tool is, there's going to be some rounding. And so you either round up if it's more than a half, or you round down if it's less than a half. I'm talking about halfway between one of these tick marks here. So the greatest possible error would be nearing that halfway mark, because the tip of that nail can be, you know, in between these tick marks. It can be, you know, up to a half, you round up or down. So the greatest possible error is half of the precision. So for example, the precision on that measurement tool here is 1/3. Half of that would be 1/6. So anyway, that's the connection between the precision of a ruler and the GPE. GPE is half of the precision. Okay, 32, convert 17 miles into feet using dimensional analysis, round to 2 decimal places. So 17.5 miles, we're going to multiply this by a conversion factor, dimensional analysis. We're trying to cancel miles, so it's going to go on the bottom. We want to go into feet, so it's going to go on top. 1 mile is 5,280 feet. Unit of measure of mile cancels out, so we get 17.5 multiplied by 5,280, 92,400 feet in 17.5 miles. What is the connection between millisecond and second? Well, there's 1,000, that's what milli means. Milli means 1,000, so 1,000 milliseconds equal 1 second. Okay, 2.5 miles per week. So 2.5 miles per week. We're going to translate that into looks like me. Okay. Well, this one might get a little tricky. We're trying to get out of 2 different units of measure. Miles is going to go into meters, and weeks needs to go into hours. So we got 2.5 miles per week. Let's first take care of the distance measurement, miles. So I want to cancel miles. First we're going to have to go from miles to feet, and then feet to meters. So 1 mile goes on the bottom. That's 5,280 feet. So now we've canceled miles. I want to cancel feet though. So feet and meters. There's 3.28 feet for every 1 meter. So now we're in meters, but we're still in a unit of measure of time of weeks. So we got to cancel 1 week is going to go on top, and that's equal to 7 days. So now we're out of weeks into days, and then 1 day is 24 hours. So we've canceled the unit of measure of time of day. Now we're into hours. We've got hours and we've got meters. So it's meters per hour. That's the correct unit of measure. So if we multiply all the values in the numerator, we have 2.5 times 5,280. That's 13,200. To multiply all the values in the denominator, we've got 3.28 multiplied by 7 multiplied by 24. It's 551. 0.04, and that's going to be approximately 23.95 meters per hour. Okay, the precision of the ruler, there's 1, 2, 3, 4, 5, 6. So it's broken up into sevenths, it looks like. There's 1, 2, 3, 4, 5, 6, 7 areas between 0 and 1, 7 equal lengths between 0 and 1. So the precision is 1/7 of an inch. Well, 1/7 of a unit. We don't know that this is in inches, so 1/7 of a unit. Okay, use a formula to find the area of the polygon. Well, this is a parallelogram. Area is equal to base times the height. So 1, 2, 3, 4, 5, 6. The base is 6 units. The height is 3 units. So area equals 6 times 3, which is 18 square units. Okay, use a formula to find the area of this polygon. Now it's an unusually shaped polygon, so what we could do is break it up into different regions. Like this one here, we could find the area of that trapezoid. We could break this up. Let's see, that might not have been the best way. You want to break it up into shapes and polygons with known area formulas like triangles and rectangles and trapezoids and parallelograms. So if you can find some of those shapes within there to break it up, that's what we need to do. So I'm thinking, let's see, we've got a triangle, another triangle, could do this trapezoid here and this trapezoid there. So it looks like we got 1, 2, 3, 4 different shapes there. 2 trapezoids, 2 triangles. So the first one, the area of that first triangle is 1/2 base. So the base is not a unit length. Okay, so that might not have been the best way to break it up. Okay, well, let's see. Let's try. So the problem is you want to have, if you're doing a triangle, a base that are unit lengths and not partial of a unit. So maybe from here to here. We have 1, 2, 3, 4 shapes, 2 triangles and 2 triangles and 2 trapezoids. We could try this. So triangle 1 is half of the base. The base here is a unit length of 1, and the height here is the height of 2. That's equal to 1. If we do the second shape, 1/2, we could say this base of 2 and that's height of 1. That also equals 1. Okay, the area of a trapezoid is 1/2. And you add the two bases. So we have a base of 1, and then looks like a base of 2, and then you multiply that by the height. And then so that equals 1 plus 2 is 3. 3 times 1 is 3. This is 3/2. And then for the fourth trapezoid, 1/2. And then sum the two bases. We have 1, 2, 3, 4. 1, 2, 3. So 3 plus 4 multiplied by the height. So this is 3 plus 4 is 7. 7 times 1 is 7. 7 times 1/2 is 7/2. So the total area, 1 plus 1 plus 3/2 plus 7/2 is equal to 7 square units. Because 3/2 plus 7/2 is 10/2. 10/2 is 5. 5 plus 1 is 7. Okay, a rectangle has a perimeter which is 2L plus 2W when it's equal to 40 centimeters. It has an area which is length times width. That's equal to 84 square centimeters. Find the dimensions of the rectangle. There's two dimensions, length and width. If there's two unknowns or two variables, you have to have two equations and solve it as a system of equations, kind of like we did. So if you recall from these processes, one of them is the substitution method. If you solve one of the equations for one of its variables, you can substitute that into the other equation. So this top equation, for example, if you move the 2W to the other side, you have 2L equals 40 minus 2W. Divide everything by 2 and you get L equals 20 minus W. So you can now take this quantity 20 minus W and substitute it in for that L. Instead of length times width equals 84, it's the quantity 20 minus W times W equals 84. So this is a challenging problem. This is a quadratic equation to solve now. If you distribute the W into the parenthesis, you're going to get 20W minus W squared equals 84. If you move all the terms to the right side so you can have one side equal to 0, that's the way you solve a quadratic equation that you learned back in 1050, is to get one side equal to 0. So 0 equals W squared minus 20W plus 84. So W minus 6, W minus 14, let me fix that 6. So the width could be 6, or the width could be 14. Now we have to solve for length for either one of those. So we know the length right here is 20 minus the width. So if we have a width of 6, the length would be 20 minus that, which is 14. Or if we had a width of 14, the length is equal to 20 minus that, which would be 6. So either way, the dimensions are 14 by 6 centimeters. 14 centimeters by 6 centimeters. Okay. The area of a trapezoid, we have to know the length of the two bases. So here's a base here. That's 5 centimeters. We're supposed to know this length, which we don't know. And then we need to know the height. And that's 6 centimeters. Now, the only other piece of information given is that the area of triangle ABC. So A to B to C, this is 18 square centimeters. Now, the reason for giving us the area of that triangle is we can break down that area into its components, base times height, to figure out this missing length right here. So area of a triangle is 1/2 of the base times the height. Well, the height of this triangle is the same as this side right here, 6 centimeters, so that's the height. And we know the area is 18, so we could say 18 is equal to 1/2 multiplied by the unknown base multiplied by a height of 6. So 18, 1/2 of 6 is 3, is equal to 3b. If you divide by 3, we get b, or the base is equal to 6. So this length here is equal to 6. And now we can use the area formula for a trapezoid. It's 1/2 plus the sum of the two bases. Remember, the bases are the two sides that are parallel, so it's that side and that side. So that's 5 plus 6. And we multiply that by the height. That's that dimension there. So 1/2 of 6 is 3. 3 times 11 is 33. So the area is 33 centimeters squared. Okay, question 40. This is 6. C is equal to 10. B is equal to 6 as well. So this is a fairly straightforward question. What's the area of the trapezoid? It's 1/2 the sum of the two bases. The bases of the two parallel sides, so it's 6 plus 10 multiplied by the height of 6. So we have 1/2 times 16 times 6. 8 times 6 is 48 square centimeters.